Okay, we're now going to talk about the fall 2019 midterm 2 problem 2. And so in this one, it says in a complete binary tree. No, we're not talking about a binary search tree. This is just a regular old binary tree, left and right children. Every level is filled except possibly the last, and the last level has all nodes as far to the left as possible, like so. And so this again is emphasizing the completeness aspect, which says like structurally, basically the tree is bushy. And so the dashed arrows here link the nodes in level order. So given a complete binary tree such as this, your task for this problem is to supply links that create these dashed arrows. We have a class bin tree that's similar to a normal binary tree with left and right pointers, except it also has this extra pointer called next that's supposed to point to the next thing in the bin tree level ordering, right? And so we have to fill in the link and level order node to take something that only has these left and right pointers basically, and all the next pointers are null, and actually fill in those null or those next values to be something other than null. So you can take a moment to think about this and how you would approach this. And there's a skeleton code on the next page of the exam. And now I'm going to sort of walk through how I would approach solving this. And I've drawn an example because I think the most important thing when you're doing a coding question for an exam is to actually have like an example input to work with. And we're going to work with the one that they gave us. So first things first, we're going to go through the skeleton and see what do I think I could fill in off the top of my head. Well, we have this line first of row equals blank, and we know it has to be something of type bin tree. Given what we already have so far, that all the information we have in this method, is there really anything we can say about what first of row should be? Well, the only type of thing we have to work with, or the only thing of type bin tree we have to work with, is this root that was passed in. And so it's a pretty safe bet to say, hey, I'm going to try setting first of row to be root, just so I can see if this works, because it's sort of all we have to work with so far. And this is a pretty common pattern you're going to notice in binary tree and tree stuff in general, is that we always start at the root and then we'll sort of recursively or iteratively work our way down. And so now I'm going to say in my little diagram, first of row points to this node, right? Okay. Looking at the next blank, then we say bin tree node is initialized to some value at first. And then we're going to say, well, the node itself isn't null. And the incrementing thing is node equals node.next. Remember, at first, all the nexts are null, and we're filling them in the course of this. And so again, the question is, what do I initialize node to be in the very beginning of our for loop? Well, again, really the only thing we know how to work with so far, right, is this first of row or this root. They point to the same thing right now. So I'm just going to set this to be first of row. Note, we can also put root here, since at this point, when the code is executing, they're always going to be the same thing. And so I'm also going to say node points here. Put it coming from this side. Okay, great. So far, so good. And now here comes the kind of tricky part, right? Where we're actually filling in the body of this for loop. And the way I would approach this is, you can look at the skeleton code for a moment, think, what could I do here again? And I'm going to think, what needs to happen? Well, the first thing is, if I were to think about sort of this root case, 0 should have its next set to this node, right? Or the first, in other words, we're setting zeros next to be like the thing all the way to the left, right? And if we look at sort of the pattern of when we reach the end of a row, which is a scenario where maybe it makes sense for node.next to be null. I don't know, I'm just brainstorming here, right? We're thinking the sort of edge case is that we always set the next in this level order to sort of be the thing in the row below it all the way to the left, right? Zero's next is going to be the row below it all the way to the left. Same for 2, row below it all the way to the left, and same for 6. And this is the pattern of an in-order traversal. And the name first of row here is sort of helpful for what this variable is going to do for us and how it's going to serve us, we can assume first of row is always going to point to the first thing in the row. So it'll point to 0, 1, 3, and 7. Again, this is a lucky guess we're making, assuming that the skeleton code is actually there to help us and there are sort of hints scattered in. That's sort of how we get better at taking these exams, is right, learning where there are hints and what information you can extrapolate even when you don't know exactly how to start. And so based on what I just said, I'm going to guess that this line is something like node.next equals, and then we want to take the first thing in the row, right? Let's look at the 2 example. Your next would be the first thing in the row's left child, because that's going to be the thing in the next row that's all the way to the left. And so node.next equals first of row dot left. And then I notice we're resetting first of row here. And so this applies to me that this condition is sort of saying when we reach the end of one row, right, we've gone here and then we're here, and we're moving on to the next one, we're going to reset the first of row. And so if initially when you're looking at this row, first of row points to 1, how can we update it when we move on to the next row? Well, we'll just set first of row to be first of row dot left again. And again, no, we could have put in node.next here since they point to the same thing. So that doesn't really matter. Great. So far, so good. And so now let's think, so far, what does my code do and what does it still have to do? Well, given what we have, first of row, going line by line, points to root. We're going to set node to be first of row. And then I don't know what happens here. But so far, what my code does is it says, oh, if node.next equals null, which it does, I'm going to set node.next to be first of row dot left. And so I'm actually going to paste these. So we haven't done that so far. We're working on it. But what I do know so far is that, okay, I would create this node.next equals first of row dot left. And then I'm going to set first of row to point here. Then when the for loop repeats, node will point to node.next. So node would also point here to 1. I'll adjust this arrow. Okay, so node points there. Cool. And then what happens? Well, we would see, oh, assuming we've sort of moved on in the for loop, we're repeating it. I don't know what happens here yet, but then we say, oh, if node.next equals null, which it does right now, right? There's a next pointer. Then I'm going to set node.next to be first of row dot left, which does this. And then I'm going to set first of row to be first of row dot left. So now we're seeing where our code sort of fails and where we need to actually, like what we need to do in this block to sort of make it fixed and do what we want. So we saw so far, it's not doing exactly what we want. And somehow we need to get this connection is the really tricky part. And so sort of backtracking and thinking, okay, what could I have done to sort of set up this connection, right? Because let's consider, so if we, let's say we had traversed all the way to the 1 node and we didn't have this connection and node points here, once I'm standing at the 1 node, is there any way for me to get back to 2 and find out, oh, that should have been my next? Do nodes have any pointers up towards their parent? And do I have any way of accessing the 0 node to get to my sort of next or my sibling? I don't, right? And so what I'm realizing is that having this pointer set up should have happened before I got to 1, or in other words, at the level before me. Because once I'm at 1, there's no way for me to reach 2. And so what I'm going to do here is I'm going to backtrack and say, okay, sort of going back to where we were earlier, when all I had was first of row points here and node points here. What could I have done in this if statement to have set up this connection so that I could have it later on? And so I'm looking at the structure and I'm going to take a guess and say, okay, I just need some way to set node.left, right, my left, to have its next equal to my right. in this particular case. And so I'm looking at the structure and I don't want to put it inside this if statement necessarily because I don't really know what that does yet, but I do think putting it here if makes sense, right? Node dot left dot next equals node dot right. And so now what that would do is point this here. Great. Now what should the condition for this be? I'm not 100% sure yet. Maybe I'll figure it out. And maybe as I get to other cases lower in the tree, I'll realize what that if statement should be. But right now, all I know is I definitely want to do that, right? And I also don't know what happens here, but we're getting a little closer. So now that we've done this, let's again see what our code does. Assuming, so the first sort of run of the for loop sets up this image, and then we increment full first in row and node to both be here. Now, we know again that sort of this row should be responsible for setting up the next row's next pointers, right? Because we saw when we were at 0, we were responsible for setting up my children's pointers. Therefore, 1 should probably be responsible for setting up 3 and 4's pointers, right? And lower levels of the tree. So what am I going to do here? Well, I would say, okay, again, I don't know what goes here, but let's just evaluate it. I would say node.left.next, which is 3, is going to be node.right. So far, so good. And then we move on, I guess, because I don't know what's going to happen. And we see if node.next equals null. Oh, but it's not, right? Because we're looking at node is 1 and node.next is not null. Okay, so we move on to the next thing of the for loop. And so now, notice we update node, but first of row remains at 1, right? Because we didn't enter this. And so now node points here because node equals node.next. And we sort of repeat and we say, hey, again, I don't know what this condition is quite yet, but I'm going to evaluate it and say, oh, node.left.next is going to point to node.right. So far, almost good. But what are we missing when we've reached the end of this? We're missing this connection, right? The 4 to 5. And so now that has me thinking, okay, when could I have done that, right? Well, backtracking a little, we notice pretty much all we have to work with up is this, right? This is the only thing we haven't really filled in besides that if condition. So maybe this is where we say, okay, I need to somehow connect 1's right child to 2's left child. And so if I'm at 1 and I want to connect it to my neighbor's or my next's right child, what should I do? Well, maybe this is where I say, if node.next is not equal to null, node.right.next equals node.next.left. And where am I getting that from? Well, let's look at the case where we were at 1 and we wanted to connect us to our neighbor's child, basically, right? Node points here. Node. And so if my next is not null, which is not, I'm going to set nodes right, so node right next to this pointer to be my node next left. And so that sets up this pointer. And so again, this is sort of thinking about the access we have here, right? When we're at 1, we have access to 2, and it's easy for us to make this connection, sort of bridging the gap from 1's children to 2's children because we have a next pointer. And so this is how I knew it should have been solved at sort of this stage when node pointed here. And so now moving on sort of back to where we were when node pointed to 2, what happens? Well, great. We successfully had everything set up. We set up the children, or our connection between our children 5 and 6, right? That's what we did here. And then node.next is null. So we're not going to do anything like setting our node.right.next to be node.left, next.left. That doesn't happen, right? But when setting it to, we see, oh, node.next equals null. And so we're going to set our next to be first of rows left. And then we update first of row. We're doing great. And so we're going to repeat this, and I'll kind of breeze through this really quick, but we see, okay, here, as we repeat, node is pointing to 3. What we're going to do, we're going to set this. Great. And node.next is not equal to null, so we skip this and we just update node. Then node points to 4. And so now here's the interesting thing. Let's say, okay, so I say node.left.next equals node.right. Okay. So node.left.next equals node.right. Well, that's null. Okay, whatever. I guess that's fine, right? Because the pointers were null to begin with. And then I'm going to say if node.next not equals null, but we don't enter this, right? Because we're looking at 4 and my next is not null. It was set up in the row before me. And so far so good, but we're starting to think, hey, what actually happens when we don't have children? And this might lead us to what fills in this final blank. But anyways, we continue on forward. When we're looking at the 4 node, we don't enter this condition and we just increment node. And so now we have that interesting case where we have no children, right? Well, what's going to happen if I try to say, oh, 5.left, which is null, right? This is a null pointer. 5.left.next should point to 5.right, which is null. Well, is null.next a thing? Does null, the concept of null, have a next attribute? It doesn't. This is what a null pointer exception is. It's when you're trying to sort of reference a pointer from null, but null has no attributes or pointers coming from it. And so doing null.next doesn't work. And so we see, oh, there's a big boo-boo here when my left child is null. And so now we know the final thing here is we don't want to enter this if my node.left equals null. So we only enter when it's not equal to null. And now we filled in all the blanks. And if you step through sort of the rest of this method, you're going to see what happens is we set 6 to point here. Also, this was set up earlier, forgot to do that. But yeah, this is pretty much the basis of what happens in the method. I recommend sort of working through the rest of the example to make sure it works, but this is how I would have approached it.